Hi, today I am going to explain you the volume 5, the internal organs, and in specific, the thoracic organs. My name is Araidaza, and this is English 3. Welcome to this in-depth anatomical tour of the heart and the structure surrounding it. Today, I want to take you step by step as if we were like in a dissection lab to understand not only the structure or the shape of the heart but also the spatial relationships, the chambers, valves, or follow pathways, coronary circulation, the lungs, the pleura, the trachea, and also the esophagus. This is so important structures in our body in a specifically in our thoughts. We are going to explore everything calmly and in detail in the next images. So now we have the location, orientation, and the pericardium. But what is pericardium? The first thing is to locate the heart inside the body. Something that most of the people imagine incorrectly. But why? Many think that is on the left, but it's really in the medium part of our thoughts. Is more centered and sitting in the middle mediastinum. This is the correct name. Right behind the sternum. The sternum, like, is the body that protects our heart and also the lung and the esophagus and trachea. From the lateral view, if we see the image in the center of the screen, we can see that the heart occupies the or is placed in the space between the vertebral column and also the sternum in front of it. It's like an anatomical sandwich. Yes, the sandwich, like when we eat the sandwich with lettuce, tomatoes, and also cheese, is something like that, but with the column, the sternum, and also the column, vertebral column. This is important because with every breath, the diaphragm that we can see in the image next to the central image that we can see in the last part, uh, the diaphragm rises and falls, and this allows that the heart moves with it. So is not like an static organ that is located only in the center or in the medium part of our body. It's work it's work between the diaphragm and also the other basals and other structures like the lungs. It's the indirectly part of the respiratory mechanisms that we can see in this part of the image. Now, the location, orientation, and pericardium, the second part. Before seeing the heart itself, the first thing that we encounter is the pericardium. When we try to, like, when we try to peel like an orange our heart, we can see like the first part that we can see is the pericardium. This is the fibrous pericardium, is the outer, so the resistant layer that grabs the heart like a firm bag that we can see in the image of the right side. Its role is so important because prevents like the heart from over distending and when it fills with the blood and to keep it in the position inside of the mediastinum. Inside in the serous pericardium, that is the pericardial fluid, um, we can see that is divided into a parietal and in a visceral layer. The latter also called the epicardium. The both the structures are the epicardium. Between them lies a space with a thin film of pericardial fluid, like act like a lubricant that allows that the um, loads the lungs, sorry, the lungs and also the heart don't create like friction and also inflammation when it moves. When this fluid increases and is more than important or more than we try to use, uh, is as a pericardial effusion. It can compress the heart and also produce the cardiac tamponade, which shows the crucial and is this important space is in our body. So now we have the external surface on the heart. But what is this? Basically, when we opening the pericardium for the first time, the heart's appearance can be surprising because it's like usually covered by epicardial fat that we can see. You, the fat is not pathological, it's not like an infection or something wrong in that is working wrong in our heart. It's like a normal part that protects our coronary vessels that are so important because allows the irrigation or allows the different the circulation of our blood in our body, and is running underneath it. From the outside, we can identify several very important anatomical groups. The first one is the coronary and or atrioventricular sulcus, which separates the atria from the ventricles. This part we can see in the video of the right side. That is like with a little crown. Yes, this is the coronary or atrioventricular sulcus. Yes, coronary. Uh, this allows to separate the atria for the ventricles. The next one is the interventricular sulcus. That is the with the UV, the V. Is named with the V, and in both anterior and posterior, which reveal the location in the interventricular septum that divides the right ventricle and left ventricle. These growths are like guiding lines of the heart, and something essential that we need to recognize are also you understand is that the atria are not on the top of the heart. For example, this is the heart. The atria is not located in this part. It's located in the posterior part. Um, they are located most posteriorly, and is this is clearly in the images that we can see in this part. I am going to play the video, so watch when I turn around the part of the video, and we can see that the atria is located more posteriorly and are attached to the great veins. Yes, the ventricles are more anteriorly, so ventricles and atris, more anteriorly and inferiorly. There are the heart also has a diagonal orientation inside the thorax. For this reason, we can see the image in the center part. The base points upward of the toward the right. The apex points downward, forward, and toward to the left. And this is why apical impulse is palpated in the fifth intercostal space, in this part of the costal spaces, and never higher because we can see only located in the apex. And the next part is the atria of the heart. The atria is divided into the right atrium and the left atrium. So, when I look at the posterior side of the heart, that we can see in the first video in the left part, the first thing I find is the right atrium. This is where all the oxygenated blood from the body arrives. And this is the importance of this part because it allows us to like oxygenate our blood after uh, after coming of our body. The superior vena cava brings blood from the head and the upper limbs. So for that reason, in the center of the screen, I put the head and also the upper limbs. The inferior vena cava that is in the last part is brings blood to the abdomen, pelvis, and the legs, and the coronary sinus that is in the centers returns blood from the heart itself. Inside the right atrium, in the video that I'm going to play in the right side, um, we can distinguish smooth regions and other more rigid areas called the pectinate muscles, which are most prominent in the auricle. In the interatrial septum is the fossa ovalis. The fossa ovalis is a remnant of the fetal foramen oval, which allowed that the blood to the pass to the atrium to the uterine atrium before the birth. From the right atrium, the blood flows through the tricuspid valve, is that we can see in the final part of the video, that is in the right ventricle. Now, like the left atrium is something more like is something more simple. Is like is located more posterior, and also it receives the four pulmonary veins that we can see in this part of the video. Yes. Um, it is a chamber with mostly smooth walls, except in its auricle, which also contains the pectinate muscles that this allows to the to do the different movements to the coordination of our heart. A clinical important detail is like the left atrium lies so close to the esophagus, so um, that when it comes dilated, because like the left atrium dilated, this can cause like a dysphagia, because it like a is like a pressure in our esophagus, and also affect the esophageal motility. So from here, the blood passes into the left ventricle through the mitral valve, that valve that is so important to the irrigation and also the digestion part. So now we are going to continue with the ventricles internal structures. So in the right ventricle is the thinner, because it's only sends like a little part of the blood to the lungs. Yes, that are the structures that is located more near nearer to the heart. So it only sends blood to the lungs, and which are very close and require low pressure. So this part of the heart don't need that doesn't need to a lot of strong in the different movements or the different electricity despolarizations. Its cavity is wider and contains the numerous trabeculae carni that uh, the cups of the tricuspid valve are attached to the chordae tendinae connected to the papillary muscles. It allows that the muscles contract to prevent the cuspus from being pushed back forward and the atrium during the systole. So the blood doesn't enter in the other cavities or the other structures in this case. The final portion of the right ventricle before reaching the pulmonary valve is called the infundibulum of the conus arteriosus. That is in this part of the video, in the right part. As that is a smooth walled region that optimizes the outflow. We can see this is um, the pulmonary portion, the final portion in the right ventricle, and also the reaching pulmonary bulb that is called the infundibulum. Is this is the muscles, the papillary muscles. and the chordate tendinae that look like little spiders. And here we have other video that shows the lung, the wider and trabeculae carni. Yes, that's this part. And then we have the left ventricle. In this part is the true pump of the body. But why? This works like a wall in several times thicker that, than that of the right ventricle because it's must generate enough pressure to send blood all through the body. Yes, it's all the body. The anterior in the right ventricle is only for the lungs, but this is for all the structures in our body. So for this reason is um, it generates pressure because have a wall thicker. It has two strong papillary muscles that we can see in the video, and the mitral valve has only two cups. The anterior valve has three cups. This, in this case, the valve has only two cups, but is the same function. Its shape is more conical and compact, and during the systole, the blood is ejected toward the aortic valve and also from there into the ascending aorta. Here we can see in the video the different parts of our left ventricle. In the next part of the video, we can see the outflow pathways of the ventricles pelvis. We have the right ventricle and the left ventricle. The ventricles have well-defined pathways for ejecting blood. The right ventricle has the pulmonary outflow that we can see in this part in the video that ends in the pulmonary valve. But the left ventricle has the aortic outflow tract. But why is this important? Because ends in the aortic valve that allows to continue the circulation of our body, of the blood of our body. Both semilunar valves functions are like gates that open with the pressure and close immediately when the blood attempts in the different parts of our head in the flow backward. Yes. The other part of this video that is so important because it's like the center of this video, and this is the most important structure and the most important function is the coronary circulation. But how it works? The heart needs also the function of the lung and also the function of the heart. The heart needs its own blood supply because it cannot depend on the body it pumps or the blood it pumps. That is why the coronary arteries exist because it allows that the dependence of the heart, and they arise from the aortic sinuses that we can see in the image of the left part. The left coronary artery usually divides into. So, for example, this is the left coronary artery. In this part, we have the purple is the left anterior descending, and then we have the circumflex artery. It's something like this. The left anterior descending, or the LID, which supplies the septum and the anterior surface on the left ventricle. And the circumflex artery is which supplies the lateral and posterior surface of our heart. Our heart is like this. This is our heart, and is how it is supplied. Is located in our heart. The right coronary artery travels around the coronary sulcus, and also the most of the people gives rise to the posterior descending artery, which determines the coronary dominance. The venous blood drains into the coronary sinus, and also which impedes directly into the right atrium. But the coronary obstruction is what causes an acute myocardial infarction, and how is and this is the reason that this structure is so important, and now how it works. And this part is the relationships with the lungs, pleura, trachea, and also esophagus. But why is this important? The heart lives around or surrounded by vital structures. On both sides lie the lungs, each contained by a pleura. The left lung has a large cardiac impression adapted to accommodate to the heart that we can see in the image of the pleura in the center of our screen. The pleura is a double membrane. The visceral pleura covers the lungs, and the parietal pleura covers the thoracic wall. So this we can see in the first part of the image. Between them is the pleural cavity. But why is this important? Because contain the lubricating fluid that also, like the pleura of our heart, this space allows that the lungs to expand without friction during the breathing. Like the heart, when we see that the pleura uh, works like this in the heart when like the heart pump in different occasions. So between them is the pleural cavity, and behind the heart is the esophagus that we can see in the right side of the presentation. It's like a muscular tube that carries the food, and also the closeness expands with cardiac diseases and can affect the shallowing. Above the esophagus is the trachea, from formed but cartilaginous rings, and its bifurcates is like this. We have like a tube, and we divide it in two parts. Is this is a bifurcation, and also is the into a main bronchi directly in from the esophagus near to the aortic arch, and the heart, lungs, and also the esophagus share the same anatomical spaces and neighborhood, which is why decides in one can manifest in their others. So, for example, see, if I have a pain in my stomach, my esophagus, I feel like a general pain in all my throats. And this is my presentation. Thank you for see this, and take care of you.